Okay, so the problem we're going to tackle today is to simplify 2 sine 15 cos 15, 15 in degrees. This is a conversation about double angle formula, and we're going to apply it to this problem once we've had that conversation. Now, we're going to start off with sine theta. Sine theta we know being the expression to represent the opposite, hypotenuse, and theta, and the relationship between these three variables given that it stays a right angle triangle. So, for example, in here, our angle theta would be that angle there. Hypotenuse is labeled correctly. This part here would be O, because it would be opposite the angle that we're describing. So we've got our O here, and that's also labeled the height in this situation, but it's not always the case. It's for the right angle triangle, of course. Now, what we want to do is we want to analyze a situation in which we have two triangles. So that is to say, I've got this triangle here and I have this triangle here, and I'm going to place them on top of each other. And this is what's going to give us two angles, hence the phrase double angle formulae. Now, how I'm going to place them is as follows. I'm going to put them in this circumstance. I'm going to place the bottom one, let me just zoom in so we can see this. The bottom one is going to be placed like this, and the top one I'm going to sit exactly on top of it. Now, in these circumstances, there's a couple of caveats that allow for this, these equations to be true. There is the 90 degrees angle of the second one, which is why there's a lean forward from this position here round to there. They sat perfectly on top of each other, so there's the 90 degrees, there's the 90 degrees of the second one. Notice a couple of things that I think that needs to be stated. Here, for this to be true, the hypotenuse, this being the hypotenuse of the bottom one, this is the hypotenuse of the bottom one there. Let's make this perhaps a size that is reasonable. Let's do there. So this is our hypotenuse of the bottom one. This is the opposite of the bottom one. There is the angle, this one's called alpha, and this AF, we don't need that C for now, that's there to aid us later, but AF, that length AF, is the adjacent of the bottom triangle. Now if we analyze the top triangle, so for example, let's say that I'm looking at this triangle with this angle in there B, beta, this top triangle, slightly different. The adjacent side of the top triangle is the hypotenuse of the bottom, because they're touching and they're equal. That length AE is the hypotenuse of the bottom, but AE is also the adjacent of the top. This is the opposite of the top, there, and the hypotenuse of the top is there. So I placed two triangles on top of each other in a certain manner, and I'm labeling them exactly the way we've done before for trigonometry, like sine theta and cos theta, or for sine theta and cos theta. Now, one other thing that's necessary before we go on to the next stage is to recognize that for the equations to work in the way they're going to, we're going to use a height and a hypotenuse, a length AB of 1. I'm not suggesting that H for the bottom or A for the top is 1. I'm suggesting that this hypotenuse up here, AB, is 1. So one of the things, I'll make this variable, I'll say AB is 1. And as I already stated, it is necessary for this to have that rule in there, that the hypotenuse of the top is equal to the adjacent of the bottom. And this will allow us to now go forward into discussions further the discussion on double angle formulae.